So a student has saved $60,000 for her college tuition. When she starts college, she invests into a savings account that pays 1.5% interest per year, compounded continuously. Suppose her college tuition is $34,000 per year, and she arranges with the college that the money will be deducted from her savings account in small payments. In other words, we assume that she is paying continuously. The differential equation is dy over dt equals 0.015y minus 34,000. And now for part A, what are the units for dy dt? Well, being that this is a model for how her bank account is changing over years, it would be dollars per year. And we see that g of t equals 1 and h of y equals 0.015y minus 34,000. To solve the ODE and write the expression for our balance as a function of time and satisfy the initial condition given, the work is, so we start with dy dt, we find the integrating factor, and we proceed to then mathematically solve to find y of t. Y of t ends up being $2,266,666 with 67 cents plus the constant, or the arbitrary constant, times e raised to 0.0515 t, where the initial condition is $60,000. So we set the initial condition for 0 time, which is 60,000, and for the t is 0. We continue on and solve for c, and we end up getting 2,206,666 with 67 cents. Our y of t model is then, as shown, $2,266,666.67 minus $2,206,666.67 with times e to the 0.015 t. So now that we have that, we can solve for t, and we are left with 0.1 or 1.79 years till she is completely out of money, as we set the condition of her balance to 0 and solve for t, and that is number 6. 7, we have a 5-gallon bucket that's full of pure water. Suppose we begin dumping salt into the bucket at a rate of 0.9 pounds per minute. Also, we open the spigot so that 0.5 gallons per minute leaves the bucket, and we add pure water to keep the bucket full. Assume the bucket's contents are always well mixed. Define y to be the amount of salt in pounds inside the bucket at t minutes. So we see that the rate of which salt is going into the bucket as 0.9, as declared in the question, and the rate of salt flowing out of the bucket would be 0.5, which is the amount it's leaving, times the amount of salt in pounds divided by 5 gallons. And the expression for dy dt of how the salt is changing over time is 0.9 minus y over 10. The initial condition for this problem is 0. To solve for y of t and satisfy the initial condition, our answer is that our workup is, we have dy dt, we find the integrating unit or integrating factor, and we proceed to solve for y of t, which we end up getting here at 6. Then we set the initial condition to t being 0. There's nothing in there, so we solve for c because we can, and we end up getting a y of t equals 9 minus 9e raised to the negative t over 10. So for our last parts, we are asked for what the pounds are at 10 minutes, 60 minutes, and as it approaches a long time. So if you plug the function into Desmos, and we find x at 10, we find a y of 5.69 pounds. If we go to 60, we find an 8.98, and this function is approaching 9 pounds over a long period of time.